So the tale of surviving a solar project surviving a hurricane. So unfortunately, as we all know, Fiona swept all the way up through the East Coast, which included the Atlantic provinces of Canada, and caused quite a bit of damage, which we saw throughout. We had several solar farms in 10 solar farms in the Atlantic provinces there, and we want to share with you guys what we did, as in planning and preparation, unfortunately, for this event in terms of designing our systems. These types of weather events are just going to get more and more, and the intensity seems to be getting more as well. And all we can do is plan what we can plan under our control ahead of time, and that's what we're here to talk about today. So joining me today on the call is Arash Yazdani, who's the Chief Operating Officer of PRI Engineering. We have Deekran Gogordian, who is our Director of Engineering here at Polar Racking, and Keith Roy, our Construction Manager. Again, I freestyled a little bit here while we were waiting for the presentation, but just about Polar Racking. Again, we've been around since 2009. We're very proud of the fact, that we're the only Canadian company in the commercial and utility scale and community solar space. Our team has a combined experience of 3 gigawatts, and we offer solar carports, fixed ground mount, as well as single axis tracker solutions. So our product lineup includes Core Flex, which is our smaller, like less than 500 kilowatt fixed tilt ground mount solution. Our Core solution, which is our larger, so community solar utility scale fixed ground mount solution. We supply lots of foundations, ground screws, ballasts, helical piles, driven piles. Our solar carports, which are the solar shield, as well as the latest addition to our product offering, which is our single axis tracker, which is the Axis single axis tracker. Again, all the information about all these products is available on our website, and we have lots of great webinars about our carports and single axis trackers and fixed ground mount that you can refer back to if you're interested in more information, or you can contact us here anytime. With that, I'll turn it over to Arash to introduce PRI Engineering.
Yeah, thank you, Vishal. So PRI Engineering is a primarily geotechnical engineering consulting firm. While we don't work only in renewable energy in the solar division, that's the bulk of our work. We've got over 100 years of combined experience, 5 PNGs, number of technicians and technologists. We've completed over 200 plus projects. And when I say projects, this is specifically in the solar renewable energy space. That's stretched as far north as Inuvik, Northwest Territories, and as far south as the Caribbean. So we've definitely got a variety of experience in a lot of different geographies. Turn it back to Vishal.
Sure, yeah. So the agenda today is to talk a little bit about the hurricane that swept through. Talk a little bit about common failures that you might see, specifically when it comes to racking systems, foundation and racking. And then to talk a little bit about what we did specifically on the Sunbank solar project as a case study. So just to talk a little bit about the hurricane, as we know, these phenomena are happening more and more. And the cost of these extend way beyond anything that we're talking about today and just in solar, but they have a real impact on society. So, just for example, there was 50 in the US, they recorded 56 weather events, weather and climate disasters between 2019 and 2021. The cost of that, the economic impact of that is estimated at over $2 trillion. And the real issue is that these things are happening more frequently, more and more, and the impact of that is happening quite extensively. In Canada specifically, what did we see here? We saw, at the heart of the hurricane, which was somewhere off the coast of Nova Scotia, 170 kilometer-hour winds, $700 million of insurance claims going in just in Atlantic Canada alone. and an estimated $2 to $4 billion of economic loss in Atlantic Canada. So what happened was very, very serious and very, severe. So
There was a question from the group that what was the speed at landfall? So the speed at landfall when the hurricane came into Nova Scotia was about 145 kilometers per hour.
okay, perfect. Yeah, no, thanks for answering that. So what's the impact of these weather events on solar, specifically, and I know everyone on this call is from the solar industry, so that's what we're here to talk about. But increased insurance costs. So not only for the people that had damages to their projects, those people are going to put in claims and their premiums are going to go up, but for future projects, everyone's insurance premium ends up going up. Lost time, because people are having to address projects. For people that have projects with damage, they got to spend a lot of time and a lot of effort, finding out what the reason was, and obviously rebuilding. Power outages, to the local communities. Loss of energy production and revenue for solar farm owners, damage to adjacent sites, and equally as important, damage to the public perception of solar, to people from outside the industry that see failures that happen due to these weather events and cast a shadow of doubt on our industry as a whole. So what are certain things that can go wrong? This slide is specifically from Rocky Mountain Institute, who did a report in the Caribbean after failures that happened out there. But in summary, there could be damage from wind, damage from snow, damage from frost uplift, damage from corrosion, and this could be caused by design issues. It could be caused by construction issues, etc. These are some of the damages that we saw, in the Atlantic provinces specifically, and that happened, for various reasons. And the only people that know are the people that worked in designing these systems. But this is just an example of what we saw online, being spread around as an impact of the most recent, damage from Fiona. So. Fortunately for us, Polar had 10 ground mount systems in Atlantic provinces. There was really no major reported impacts of the damage on our foundations and on our structure and on the modules. And we take great pride in that fact, because we do follow the engineering, as close, to the letter, I should say, of the law as we can. And, just speaking on our behalf, we feel like that's been a big contributor to our success. All these 10 farms are farms that the installer has never touched before. In every one of these cases, we know that solar is new to the Atlantic provinces, and it was an experienced installers that had, lots and lots of Polar racking installation under their belt. Every single one was a new installer, but every single one survived, and we feel like, as we'll get into and moving ahead, there's the way that we go about looking at these farms. There's a contributing factor to that end result. So with that, we're going to talk specifically about the Sunbank solar project. It is 21 megawatts AC, 26 DC, owned by the city of Summerside. And, we were awarded this project early this year. It's still under construction, actually. It's still underway with the large parts of the site built. It is important to note, while a project is under construction, that is when it's most susceptible to having issues, because we had, the installers have not had a chance to go all the way through and do all the QC and QA that they would normally do, checking at the end. And despite that fact, there was little to no damage at all on this site suffered during the wind events that swept through Summerside. So I will turn it over to our Director of Engineering, Deacon Gregorian, to talk a little bit about some of the design considerations in our racking.
Thank you, Vishal. For Summerside Solar Farm design consideration, we took the soil conditions into consideration, the topology, wind speed, snow loads, corrosion requirements in that area, and availability of equipment and concrete install different types of foundation, module bonding support requirement to withstand increased loads. Now, next slide, please. Now, the most important thing in engineering is to follow disciplines, engineering disciplines, and go through them and make sure that each dot is crossed and everything is perfect. Initial pre-production testing program we do, third-party review, like whenever we design everything to specification, we basically ask the third party to check and verify all our information. Design with Canadian climate in mind, complete production testing, quality assurance and contractors, complete of golden table construction at Polar, with Polar at the construction site, meaning that we go to the site and we build a table or a row and quality check it and verify and train the customer or installer. And a total 7 site visits by Polar and PRI personnel. Like we go to the site, we're not shy of visiting site, and we always stand there with the installer. Now, what was our challenges when we started designing the Summerside project? The high snow loads, 31 kPa, and also which is per NBCC 2005 requirements, building code, and the high winds, which were like 0.6 kPa per NBCC 2015 code. Now, 0.6 kPa, just to do a small math there, 0.6 kPa is equal to 110 kilometers per hour average hourly wind speed, which is equal to 150 to 160 kilometer per hour gust wind, which is equal to 1.1 kPa. Basically, this was our design criteria when we started doing our design. Our observation from the speeds that we saw in that area from Environmental Canada, average hourly speed, wind speed was recorded as 89 kilometers per hour. As you can see, like on the chart next to it. And from Weather Network, max gust winds were recorded as 131 kilometers per hour at Charlottetown. Now, in general, we have various different types of PRUs or ground mounts. If we're doing, you can do it in Caribbean, Alberta, Ontario, and Atlanta, Canada. Let's say we just put some examples here. And if you look at like when you go closer to the equator, you would go more in flat mode because you want to get the most production. When you start going up north, you would start getting the tilt. And we in Ontario or in PEI, we have like 25 to 35 degree angle. And the tilt angle factors are more or less the maximum production angle to get. The snow dumping, if you have like in Ontario, you have to have it like in an angle so that you can dump the snow, that will help. You also consider the shedding of the snow and the row spacing. Now in Caribbean, if I put some numbers in the bottom there. I'm not sure like if you are guys seeing that.
Yeah.
Okay. I put some numbers there in the bottom, like Caribbean 105 miles an hour wind. basically with zero PSF snow. Alberta is 0.5 kPa wind, 1.7 kPa. This is like a normal site that we do. And the high side is basically in PEI, you had like 0.6 kPa and 3.1 kPa snow. If you look at the calculations below on how the factor loads on pile is acting on the pile, you would see like from Caribbean, which has 105 miles per hour wind, your bending moment basically is 31.5 versus like if you look at PEI, your bending moment is 60.5, almost double. So you have to take all these into consideration when designing your table. And continuing with our disciplines, basically we perform wind tunnel tests. And we currently have 4 different wind tunnel tests in our possession, like that we perform with CPP and RWDI, both reputable companies. And the reason why we did 4, because over time you would start getting bigger modules, and with bigger modules, or you would get different angles also. To accommodate that, you can't just do interpolation. You need to be within the requirement or the specification of the wind tunnel. So we do perform that just to have our coefficients proper. And if we're doing in the States, we perform our calculation with ASCE 710 building code. And if we're doing in Canada, we go with the NBCC 2015 building code requirements. Every time that we finish our design, we always send it to a third party for approval and stamping, because we want to make sure that all the calculations is correct and there's another set of eyes looking into it and approving it. And clearly the specification allowed, like, we always make sure that customer understands every variation that there are during the build, like how much variation you have on installation, on connections, embedments, plumbness of the piles, fastener torques, which is very important. And we put like also the range of torque tolerance that you can have in there, so that they would know that if they're within, they will be secure. We do test design. We test all our connections, and we do a correlation with the analytical calculation. This is extremely important item that we put a lot of effort on, because once you do a proper testing with proper correlated analytical calculation, from there on, any other connection that you want to do within that type of connection, you would know that whatever analytical calculation you do, you're dead on the number. And part quality verification and inspection, we do that thoroughly. Site build quality verification, we're always on the site again, as I said before, that we do our checks and verification on site. Oh, we do also, sorry. We build golden tables in a row with customer, and make sure that the installers are trained to the requirements that we have. Document voice of customer, installation concerns. A lot of times, like we being a front runner or a good company on engineering, we also try to better ourselves. Like we want to learn from voice of customers, installers, so that in the future we will have better designs. So we always take into consideration and build it in our lessons learned database. We're always hand in hand with the customer during the build, and we evaluate every discrepancy that they have, and we provide solutions and approvals for it. just to ensure that that at the end nothing is going to happen to these tables. And also, we take pride ourselves for doing constant R&D and VAV activities to improve design without sacrificing structural engineering. Now, we are partnered with PRI. I mean, we're one happy family, and we basically literally sit next to each other. And if you consider like anything as racking and pile, bringing it into one spot, I mean, you would design much better piles and much better racking because you would be very optimized and to the requirement.
Okay, thank you, Dikran. Thank you for that. So just wanted to take a couple of minutes to just talk through everybody the process that was gone through to determine the foundations for the Sunbank solar project. When we're looking at a solar farm, or any project, mind you, we always start with doing a desktop site evaluation. One thing that is sometimes common for other engineers is that, let me just go back, is to they've got a common solution that they've used in the past, and kind of not considering any of the facts of the site, they will start designing. And we never want to do that, because you always kind of want to go into every project with an open mind for any possible design. So we're looking at things like elevation of your groundwater table, presence of cobbles and boulders or other subsurface obstructions. In the case of the Sunbank solar project, or many of the projects that would have been built in PEI, PEI, for anybody that's traveled there, is very well known for its beautiful red soils. And that's because of the red sandstones that are rich in iron. And those sandstones are, they could be anywhere from 1 meter or 2 below grade, and they could be as deep as 5-6 meters below grade. But the point I'm trying to make here is that condition represents a subsurface obstruction, which must be considered during design. And we'll get to that in a section. Identification of bedrock elevation. So I already talked about, the variability of the bedrock elevation on PEI, and predominant subsurface soils within the zone of influence of the foundation. So within your zone of influence of the foundation, that's typically known as, an area about 3 times the diameter of the foundation. In these cases, it's only about a 6-inch to 8-inch foundation element. So that zone of influence is typically small when you compare it to maybe like a large structure, like a house or a high-rise building or anything like that, where the foundation could be meters and meters in length. Next slide. Specifically, what did we do at the Sunbank solar farm? So a variety of driven W sections and driven round HSSs were tested. So we actually installed 20 W sections and 20 round HSSs at the pre-production stage. I believe it was actually kind of around this time last year that we started that process. And from the pull testing, which all pull tests were completed, axial pull tests to ultimate failure of the foundation, we had this hypothesis that the round HSSs would be significantly stronger, and that's exactly what the pull testing told us. It confirmed that the skin friction. So just think about the friction between the soil and the steel pile, which is ultimately what will give you most of your resistance for wind resistance or frost resistance. It was 2.4 times greater for a round HSS versus a W section. So that's, that I don't think you need to be an engineer to, realize that is a significant amount. If you can have 2.4 times for something that is of equal length, greater resistance, it's almost a no-brainer. You go with the material that's got the significantly greater resistance. The other major concern, and this is something that a lot of foundation engineers do not think of if they're not familiar about solar foundation design, is constructability. Sunbank had something somewhere in the ballpark of about, I believe, about 5,000 foundations. There's solar farms out there that has 250,000 foundations. So if you even get 1% of that incorrect, that could represent a very, very large change order for the contractor, a very, very large change order for the developer. So, we did have a concern when we were going initially through this testing process of whether the W section would be able to adequately penetrate the underlying weathered bedrock. And the results confirmed that was a correct hypothesis. The W sections were not able to penetrate the underlying bedrock, and the round HSS were able to do that very, very effectively. That is actually why we had 2.4 times greater than skin friction with the round HSS versus the W section, because typically what happened with the W section is once you hit that bedrock layer, the W section would stop and maybe advance a little bit further, but for all intents and purposes, negligibly advance further. Whereas the round HSS was easily able to kind of penetrate about a half meter to about a meter into that material. Once that pile made it into that bedrock layer, it was not going anywhere. There was no chances that it could pull out. It basically locked right into the rock. So, that was what we did during the pre-production stage. One of the other kind of big downfalls for a lot of solar farms is that, they feel like, okay, we've done all this geotechnical work, we've done this pull testing, we got our stamp drawing, we've ordered our piles, ready to rock and roll. And there's never enough attention to quality assurance and quality control. A lot of you may have heard of a lot of failures of foundations in the Ontario solar market, and a lot of that had to do with a lack of quality assurance and quality control. So that's why when we act as the engineer of record, we're very adamant, and we know we can't force people, but that's part of how we choose our partners. Is we look to team up with contractors that understand the importance of this step, because this right here is critical for a successful project. So through the construction process, as Deacon and the rest of the guys mentioned, PRI personnel went to site. They oversaw installation. They made sure that the contractor doing the pile installation understood the specifications, made sure that they understood how to fill out the approved quality control forms. And if they didn't, they would have corrected them so that, issues wouldn't drag on for thousands and thousands of piles. We were there week one of installation, making sure that these things were taking place. If anything didn't meet any of the design requirements, that would have been flagged by our team. So when the contractor created his as-built record of installation data, they would send that back to our team, and our team would review that. If anything didn't meet, they would flag it, potentially would test it, we'd do some more testing, or we would recommend a remediation design. There was, less than 2-3% remediation at the Sunbank solar farm. Typically, they say anything less than like 5 to 10% is a successful site. So we were very, very happy with the results at this site. And so here we got photo before Hurricane Fiona of Sunbank Solar Project on the left, and on the right you can see a close-up picture of the racks, and there was little to no damage. There was damage on 4 tables, but those 4 tables had already been flagged by the Polar construction manager as having deficiencies, and they knew that corrections were needing to be made. So any remediations required to the racking were already remediations that were already accounted for and were known in advance of the hurricane going through.
Yeah, thanks for that, Arash. So again, with that, the reason that we're here today is because we wanted to share our design methodology and our best practices. We feel like it's an important thing to do in the solar industry in general, in all aspects of the design and execution of these projects. As our industry continues to grow and as we continue to see what works and what doesn't work, the only way that we're going to get better as an industry as a whole is to share. With that, we're going to open it up to questions right now. So as you have them, please send them through, and we're happy to tap on the the resources we have here to answer your questions. And if we don't have the right person in the room, I assure you we will back to you. So I'll jump into some of the ones that are already there. We already talked about the wind speed one. So what is the normal nominal tilt angle that you're setting the modules at that latitude? So typically what we're seeing in Canada in general is anywhere from 25 to 35 degrees tilt, with 30 being the most common, that we've seen so far. So that question is from R. Fryer. So, and then he had a follow-up question: have any of your design required added or beefed up structural elements, say purlins, for example, in order to brace modules against the effective winds? Yes, yeah, 100%. So if you look at our design here, we have beefed up braces at the bottom. Our north-south beams and our east-west beams were a heavier gauge thickness rack, and again, it's all exactly what Decran said. To when we start a project, we look at the wind and the snow load, specifically when it comes to the structure, and based on that, we size our members. Now at Polar, we're not big on adding lots of extra braces, because we feel like the more parts you have, the more connections you have, the more opportunity you have for something to fail. So we opt for beefing up our primary members rather than adding, supplemental bracing, as much as we can, where we can. And that, that like this project is an example of that for sure. So Connor asks, how do you handle bearing embedment depths? Are piles trimmed to correct the height after install? Should I give that one to you, Rash?
Yeah, sure.
Yeah.
So to simple answer your question, yes. Maybe I'll elaborate a little bit. So we do provide a quality control measure based on drive times of the installed piles. So if they meet those requirements, they're allowed to prematurely stop the installation as long as it meets, certain criteria. In those cases, they would cut the pile. One of the benefits to the Polar racking system is that they are able to attach to a round post directly. You don't need a conversion kit or an adapter kit, which a lot of systems that can only adapt to a W section will require. So that's advantageous, because you can obviously adapt right to that round section. But the other advantage is a lot of W sections, they will have a bolted connection directly to the flange of either the flange or the web of the section. And for a bolted connection, you need to have very, very precise tolerances for your vertical. Whereas when you have a friction clamp, you have, somewhat unlimited degrees of freedom, because that clamp can technically clamp anywhere to that pipe. It could be, a couple inches off ground, which, isn't practical, obviously. And it could be, right to the top of the pipe. In some cases, you wouldn't even have to trim the pipe, as long as it doesn't interfere with the purlins up above.
Exactly. Have you designed our prior, again, thank you for your questions. Have you designed any arrays at higher tilt angles, say 45 or 55 degrees? Yes, we have. Yes, we have the wind tunnel data to allow us to do that. Typically, we wouldn't do this for a project less than 1 megawatt. However, yes, the short answer is yes, we're absolutely able to do that for you.
We've done 45.
We've done 45, yeah.
I mean, accordingly, you have to beef up the materials, right? The purlins and the north-south beams and so on.
So really, like at the higher tilt, the snow plays less of a factor and the wind plays a more factor. So depending on where it is, if you're in an area with very low wind and, very high snow, like, 45 degree might not be that much heavier. If you're in a very heavy wind area, let's say PEI, like a 45 degree rack would be significantly, beefier where the winds are higher. So, the answer to your question is absolutely we could do it. And it's all, a balancing act between the loads to provide a structure that's going to last.
You wouldn't be up to those high tilt angles in PEI. Like that was where we used 45 degrees was up in the Arctic Circle.
Yeah. I think we could do it, but we wouldn't.
It wouldn't have the benefits
Yeah,
for the project, is what I'm trying to say.
Exactly. Yeah, for sure.
From a generation standpoint, that is, of course, which is ultimately what drives a lot of what we do here.
We'll give another minute to see if anyone else has any other questions. So it seems like there's no more questions. If you guys do have questions, the contact information is below for polar racking and PRI. I would like to thank my co-presenters today, Arash Istani, Deacon Gregorian, our Director of Engineering here, and Keith Roy, who is on standby to answer all your construction questions. He's actually on a site in Boston today, so we appreciate him taking out the time and being here for us. Again, thank you as well, all for your time. Sorry, the last thank you was for Janet, our marketing manager, for helping us put all this together and for getting the word out. And yes, thank you all for attending and participating in this webinar. We know your time is valuable. We hope we brought some value to you today, and we look forward to working with you on projects moving forward. So thank you very much. And have a great day, everyone.